this video, I'll teach you about arithmetic sequences. Specifically, I'll give you answers and solutions to the DepEd Learning Module for grade 10. Let us start. So what is an arithmetic sequence? It is a pattern of numbers that increase or decrease at a constant amount. For example, 2, 4, 6, 8, 10, and 12. So from 2 to 4, you will get plus 2. To get a 6, you'll get plus 2 until you get a 12. This number is what we call a common difference. If your common difference is positive, that means to say that your sequence is an ascending sequence. But if your common difference is a negative number, that means to say that your numbers are going down or your sequence is a descending arithmetic sequence. To find any term of an arithmetic sequence, we use the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub 1 is the first term of the sequence, d is the common difference, and n is the number of terms defined. Now, so you can understand all things that I've been saying here, let's have the examples. Let's have the modules now. Right, so we start with activity 6 because all the other activities in the DepEd module for grade 10, specifically for Unit 1, are actually easy to answer, so I've decided to start with activity 6. So let's start. Find the missing terms in each arithmetic sequence. Number 1, we have 3, 12, 21, and we need to find the next 3. Now you would see that from 3 to 12, we added a 9. From 12 to 21, we added a 9. That means to say, to get the next term, we just need to add 9. So that should give us a 30. And you add another 9, so you'll get 39. You add another 9, and then you should get 48. So the answer to number 1 is 30, and then we get a 39 and 48. And you just need to follow this pattern so you can get the other answers. But let's have a look at number 2 first. In number 2, we have a3, negative 2, and we need to find 2 more terms. In here, it's obviously going down, so we expect a common difference that is a negative number. So now from 8 it becomes 3. So what do we add to 8 to make it a 3? Well, the answer is negative 5. That means to say, if you add negative 5 to 3, it will get to negative 2. That means to say it's the same number we will use to get the other numbers. And negative 2 plus negative 5 should be negative 7. If we continue that, then we will have negative 12. So the answers for number 2 are negative 7 and negative 12. If you do the solutions we did in number 1 and 2 to the others, then you can answer everything else. And that's how we get the answers to number 3, 4, 5, 6, 7, 8, 9, and 10. You can replay the videos so you know how to get the first 2 numbers, but these are the answers to the rest of the items. Now we will go to the second part of this activity. It says here, find 3 terms between 2 and 34 of an arithmetic sequence. So we know that there are 5 terms all in all. The first one is 2, and then the middle 3 numbers are missing, and the last one is 34. So how do we solve this? So first you just need to know how many jumps you need to do before you get to 34 from 2. So from 2 we have 1, 2, 3, 4. So to get into 34 you need 4 jumps. And how do we get our common difference? It's very simple. You just need to subtract 34 with 2. So that means 32, and divide it with the number of jumps that we need to do to get into the last term. So that means 32 divided by 4, 8. That means to say that our common difference here is 8. It's positive 8 because from 2 we are heading towards 34, which is an increasing number, or rather it's a bigger number than 2. So we obviously know that this is going to be an ascending number. That means to say that a common difference will be positive. So 2 plus 8 will be 10, plus 8, it's 18, plus 8, that's 26. So we now have our three terms between 2 and 34. And that's how you answer it. To continue, we will now have activity 10, and obviously I skipped activity 7 and 8 because I think this is where students really need help. So for this activity, it says you use the nth term of an arithmetic sequence where the formula is given to answer the following questions. First, find the 25th term of the arithmetic sequence 3, 7, 11, 15, 19, and so on. Now, if you want to do an intuitive solution, you can actually do the listing way because you are already given the first few terms. So you can do 3, 7, 11, 15, 19 and just continue the pattern. You can see that the common difference here is 4. So you can just do a continuous adding until you get to the 25th term. But if you want to use a formula, then you just need to substitute what we are looking for and what we have to the formula. So we start with the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. In this case, we're looking for the 25th term, so we substitute our n with 25. Our a sub 1, as you can see in the given, is 3, and although it's not given, it's not directly given in the problem, we can deduce, we can get it from the sequence that the common difference is 4, because to get to 7 from 3, you will have to add 4. The same goes to 11. So from 7 to get into 11, you get 4. That means to say that a common difference is 4. So we just substitute those values so we can get a sub 25 or the 25th term. And then we do all the substitution and the computations, we should end up with 99. Right, that's our first problem. Let's have the second problem. So for the second problem, the second term of an arithmetic sequence is 24 and the fifth term is 3. Find the first term and the common difference. For the second problem, it's very important that you're able to visualize the given and the things that we need to get, so it's faster, so we can solve it faster. Now, so I have here the first term is missing, we have the second term, the third and the fourth terms are also missing, but we have our fifth term or the last term in this sequence. Now, if we do the same solution as what we did earlier in activity 6, specifically the last part of that activity, if we do the solution there, disregarding the first term here, so that it would seem that 24 is our first term, then we would have 3 minus 24, which is negative 21, and there are 3 jumps from 24 to 3, so that should give us a common difference that is negative 7. Right, now that means to say that to get from 24 to 3, we would have to add 2 negative 7 to get to 3. And because we're looking for a sub 1, instead of adding negative 7 to 24, we will be subtracting negative 7 to 24. That means 24 minus negative 7, which will give us 24 plus 7, which is positive 31. So obviously our a sub 1 will be positive because we are moving to the left, and this is a descending arithmetic sequence. Obviously it will be bigger on the left compared to the ones to the right. And so we're able to get now the missing items that were asked of in this problem. So this is a solution, the same that we did. It's the same solution that we did in the previous activity that I've shown in this video. Now off to the other solution that we can do for this problem. So we can do this solution wherein we use the formula. So again, our formula is shown: a sub n is equal to a sub 1 plus the quantity n minus 1 times d. If we disregard this term and assume that 24 is our first term, that should leave us with 3 as our fourth term. So for this problem, I will be using 3 as the a sub n. 24 is our first term, and because 3 has become a sub 4, then my n would be 4. And because we don't know the common difference, then that should remain unknown. If we do algebra and do the solution, then we should end up with d being -7, which is the same as the other solution that we have. Now, since we already know our common difference, that we can go back to the formula and really solve for the first term. And this time, I want to use 24 as my second term already. So it will not go back to the original given, wherein the first term is really missing. But this time, I'll use 24 as the actual second term. Right, so in my formula, I substitute n with 2, so I have a sub 2 is equal to a sub 1 plus n, which is 2 minus 1, and this time I will be using my computed common difference. So please take note that if you will be using numbers that you've solved or that you've gathered or you've solved in your previous workaround, you have to be careful that it's really the correct number that you're using, because if it's a number that you got from a solution that you yourself made, if you got that solution wrong, then the substituted number will be wrong, which means that it's going to snowball and everything else will be wrong. So you have to be really careful with this, okay? Now, going back to the solution, we have here a sub 2 equals a sub 1 plus 2 minus 1 times -7. And if we do the algebra, that should leave us with a sub 1, which is 31. And it coincides with our previous solutions. So therefore, we have the correct one. So these are the two solutions that I've come up with that you can use to solve this problem. Of course, there are other solutions, but these are the ones that are easy to do and easy to understand. Let me know in the comments if you have other solutions to the second problem. Right, now let's proceed to the third problem. Give the arithmetic sequence of 5 terms if the first term is 8 and the last term is 100. Well, this one again is very familiar, correct? It would seem so, because this is actually the same as the one in activity 6. Now, I'll give it time to answer it. Right. Alright, I hope you have your answer already, but this is my solution, so I hope we have the same answer. Let's see if you got it right. Illustrating the problem, you would have again the first term, which is 8. There are 3 terms in the middle which are missing, and then we have 100 as the last term. Now if we do our solution in activity 6, then we have 100 minus 8, which is 92, divided with the number of jumps to get from 8 to 100, which is 4. So that's 92 over 4, which is 23. So that should give us the common difference again, which is 23, and we do the adding. So that should be 31, 54, 77 for the terms in the middle. I hope you get it right. Please comment down below also if you have other solutions other than the one that I've used. Well, you can, in this case, in this problem, I actually did not use the formula because it's actually a lot faster than using the formula. Now, let's proceed to the fourth problem. This time, we need to find the ninth term of the sequence. We're given the first term and the common difference. This problem is actually a very easy one, because all you need to do is just really substitute the given into the formula. So again, this is our formula. If you have noticed, I actually color-coded it so you can see which one needs to, or which one is substituted to which. I actually do not want to get into the computations because you can just input this in your calculator so you can get the answer. So for this one, the answer is 6. So the ninth term of this sequence here is 6. Right now, let's proceed to number 5. Find a sub 1 if a sub 8 is equal to 54 and a sub 9 is equal to 60. Again, it's very important that you try to write it down, to write a given, so you can visualize and better understand the problem. Now, you would see that a sub 8 and a sub 9 are actually adjacent terms. That means to say it will give us, these terms will give us the common difference right away. So from 54 to get into 60, we added what number? Right, we added 6. And because we need a sub 1, which is to the left of the given, so if we have 6 as our common difference, and this is an ascending number, that means to say from 54 to get into 60, you added a 6. That means to say, if you want to go backwards, or if you want to go to the left of the 8th term so you can get a sub 1, that means to say you have to subtract the common difference, which is 6. So 54 minus 6, that should give you the 7th term. If you continue that until you get into a sub 1, then you will get the right number. And we have this one. So you can just you can just use your calculator and do the subtraction. So 54 minus 6 is 48, 48 minus 6 is 42, and so on. And you have to be able to get into a sub 1. Right. That means to say our a sub 1 is 12. You have to be careful because you might get into the very low numbers if you continuously subtract 6. You have to know that there are just 9 terms here. Okay? So you have to subtract the right number of 6's. Okay, you cannot go beyond. Right. Let's go to the next number. How many terms are there in an arithmetic sequence with a common difference of 4, with the first and last terms 3 and 59? Again, it's very important that you write it down so you can better understand and see what the problem really is about. So we have 3, there are a couple of terms in between, and then the last one is 59. The number of terms in between, that's exactly what we're looking for. But we do know that the common difference is 4, correct? That means to say that before 59, there must be 55, correct? And if you continue subtracting 4 minus 4 minus 4 minus 4 until you get a 3, you will eventually know how many terms there are in between. But the problem is, it might be quite tedious to do that because 55 is quite far from 3. So what do? We can use the formula because we have the things that we need to know. I mean, we have first, we have the common difference, we have a sub 1, and we have a sub n. It means to say, we can just use the formula. So after we have substituted our a sub n, our a sub 1, and our common difference, which is 4, if you do the algebra, there are actually 15 terms all in all. Right? So that's our answer. There are 15 terms. Now let's have the 7th item. Which term of the arithmetic sequence is negative 18 given that a sub 1 is 7 and a sub 2 is 2? Right, again, we need to write it down so we can see the behavior of the sequence. We have 7, 2, there are terms in between, we end with negative 18. So you can see that this is a decreasing pattern. That means that our common difference is negative. So from 7 to get into 2, we add a negative number, which is negative 5. So 7 plus negative 5 is 2. And if we continue that pattern, it should lead us to negative 18. We don't know yet what the value of n is. But we do know that 18 is our a sub, negative 18 rather, is our a sub n. We know our a sub 1, which is 7. And at this point, we know our common difference, which is negative 5. Now, if we substitute all those values to the formula, then we end up with this. We do the algebra, and we get 6 as our n. That means to say a sub 6 is equal to negative 18. Now we have to be clear that negative 18 is the sixth term. You cannot just say n is equal to 6 because 6 is actually the position of the term, but it is not the actual term. Okay, you have to answer the question. You cannot just solve the position. So the correct way of answering it is negative 18 is the sixth term. You have to be careful with that. Right, now let's go to number 8. Before I solve or give you the solution to number 8, it's important to note that this problem is actually a parallel problem to number 6. If you read it closely, you would see that these are two similar problems. And with that, I'll give you time to answer it and try to recall the solutions we did for number 6. Great. So the answer is 14. And we say it correctly, there are 14 terms. It's very important that you know how to answer the questions and not just really say n is equal to 14, right? So go back to the question and answer it so your final answer will be correct. Right, now let's go to the next number. What must be the value of k so that 5k minus 3k plus 2 and 3k minus 11 will form an arithmetic sequence? Again, we write it down so it's easy to understand the problem. So I have color-coded it. As you can see, color coding is the key to any problem. Right, now 5k minus 3k plus 2, 3k minus 11. Now, we know already that there should be a common difference among these three terms, correct? And this common difference being common must be equal to each other, right? That means to say, if you subtract your second term with your first term, that answer you get must be equal to when you subtract your third term with your second term. And then, so we do that, k plus 2 minus 5k minus 3. Please take note that we need to put it in parentheses because that will really matter. So for these terms to form an arithmetic sequence, then k should be 3. Now let's test that if it's really correct, because you might be wrong along the way, right? So if you have 5 times 3 minus 3, that should give you 12, and then 3 plus 2, which is 5, and then 3 times 3 minus 11, which is negative 2. Down to the last number. Almost there. Find a common difference of the arithmetic sequence with a sub 4 equals 10 and a sub 11 equals 45. Quite similar to the previous ones we've done already, correct? I'll give you time to answer. Try it. Right, so the answer is 5. And our conclusion should be the common difference is 5. Again, it's very important that you state your answer in a complete sentence form so that anyone who should be grading your answer or anyone who will grade or read your answers and solutions and final answers would get it right away. We're finally done, and great job for today. That's it takes a lot of patience to complete this module, but we're actually not done with the whole module for Unit 1. If you want me to answer the rest of the module, then just comment it down below. And also, please do not be shy to comment your solutions so I can also check it out, because there might be things that I missed, or if there's any mistake in the things that I've just shown you, then do not hesitate to call me out on it, okay? And I'll see you again in my next video. Please comment down below what you'd like me to discuss further so I can help you out. And this is NicaBZ, and I'll see you in my next video. Please like and subscribe. Bye!